Welcome to the second part of our series on the architecture of Entra Connect. In this segment, we'll take a closer look at its internal structure and understand how the components work together seamlessly to manage identity synchronization. Let's dive in. The connector space is a staging area within each connector. It holds designated objects and their attributes from a connected data source. The connector space serves two main purposes. It tracks incoming changes from the data source and stages outgoing changes for export back to it. Let's understand the features of the connector space. Each connector has its own space, ensuring the sync engine can continue processing even if the connected data source is temporarily unavailable, which help us to search object within the connector space. The sync engine detects changes made since the last sync and only pushes unsynchronized data, reducing network traffic.
Tracks the synchronization status, evaluating new data against already synchronized data to prevent redundancy. The connector space stores only the attributes that are specified in the inclusion list, focusing on the relevant data for efficiency. With the connector space, the sync engine ensures optimized, efficient synchronization by managing changes and focusing on relevant attributes.
Let's talk about the metaverse, or MV, the core of identity integration in Entra Connect. The metaverse is a global storage area that integrates identity information from multiple connected data sources into a single, unified view. Aggregation: the metaverse combines data from all connected sources into one centralized repository. Rules-based synchronization: using admin-defined rules, it aggregates, transforms, and manages identity data across systems. Identity management: it resolves duplicates, consolidating objects into a single, comprehensive identity view. Let's talk about sync engine identity objects. These are representations of objects, either from a connected data source or from the sync engine's own integrated view. Every object has a globally unique identifier, or GUID, which ensures data integrity and defines relationships between objects. Now, within the connector space, objects from connected data sources are represented here. Each has a GUID to ensure uniqueness, a distinguished name, or DN, for structured identification, and an anchor attribute, like an employee ID, used to track an object's identity. This anchor is unique and doesn't change during the object's lifecycle. There are two main types of connector space objects. First, staging objects. These represent data during the import or export process. They include a GUID, a distinguished name, and a type indicator. Staging objects can be flagged as pending import when new data is received but not yet processed, or pending export when data is ready to be sent. Staging objects are further divided into import objects, created during data import, and export objects, used for outgoing data.
Finally, let's cover anchors in the connector space. Some connectors, like Active Directory, automatically generate anchors using attributes like object-list. For connectors without a default unique identifier, anchors can be manually configured to ensure each object has a unique identity. That's a quick overview of sync engine identity objects and the connector space.
Thanks for watching. In the next part, we'll explore the flow of data, how an object syncs from on-premises to the cloud and back from cloud to on-premises. If you found this content helpful for your learning, please like, subscribe, and share to support the channel. Stay tuned for more insights, and see you in the next video.